we know certain places on Earth get sunlight for 24 hours straight, meaning the sun stays up in the sky in these places for over 24 hours, never setting, never moving away for days, weeks, months at a time. And while the people in these places never see the sun leave the sky, people on the opposite end of the earth are watching the sun set, watching the sun go down below the horizon at the same time on the same day. The sun is going down below the horizon on one end of the earth and sitting in the sky, not rising or setting, on another end of the earth at the same exact time. It's rising and setting every single day closer to the equator. And as you move away from those places on the equator, moving closer to the poles, closer to where the earth would be rotating a lot less, where you're going to see objects in the sky dropping below the horizon a lot less. The sun is no longer dropping below the horizon. It's basically sitting out there beyond the horizon for these long periods of time, not going anywhere, not changing size, barely changing its position. So on one part of the earth, you've got the sun looking like it's moving around the curvature of the earth. And at the exact same time, in a different location, you got it looking like it's just sitting in that one specific area, moving around that one area beyond the horizon and never leaving the sky. You got these two separate things happening at the same time in different parts of the earth. And this makes a lot of sense. If the sun is out there beyond the earth, beyond the horizon, at a distance, sitting in one place, and the earth is moving around it, which is causing us to see the sun from these different perspectives all at the same time. Again, we have 4 seasons. And one of the aspects of those 4 seasons is the sun never setting in different parts of the earth. Never setting, sitting in the sky, out beyond the horizon. Again, while it's going in a completely different direction in a different part of the earth, dropping completely below the horizon without changing size. So we know the distance isn't changing because everybody on earth is also seeing the same angular size of the sun everywhere on earth, even with all these different movements from our vantage point, from our perspective on the earth, moving around it. And the different motions of the earth are giving us these opposing points of view of the sun all at once, all over the earth. Because you got to think, if the sun is moving around the earth, then we should be seeing uniformity in the way that it moves. It should be moving the same way everywhere on the earth. One distinct movement, one specific position. But we're seeing different orientations, different motions in different parts of the earth, all happening at the same time. And these different motions and orientations fit what we should be seeing on a spherical earth, rotating and moving around the sun at a distance. But if the earth is making a circular motion around the sun, moving around the sun in a circular motion, then that means that it's making a 360-degree revolution. It's making a full uniform rotation around the sun. And because it will be moving around the sun in a full rotation, a full 360 degrees, that circular path around the sun would not be measured in miles per hour because we'd be dealing with circular motion, circular rotation. Again, that rotation would be measured in RPMs, revolutions per minute. And again, you can look at it this way. The earth makes a full 360-degree revolution around the sun, one full 360-degree turn, one time every year. One full 360-degree movement around the sun, just one time every year, every 365 days. So it takes a full year 365 days for the Earth to revolve around the sun just one time. Remember, we have 4 seasons, and 4 seasons equate to 365 days. So that means the Earth is making a 360-degree turn around the sun in 365 days. So to get to 360 degrees in 365 days, the Earth would have to rotate around the sun just about 1 degree a day. Again, 360 degrees in 365 days. So every day, Earth will be moving about 1 degree forward within that circular path. And again, those 360 degrees of rotation are measured in revolutions per minute. And just 1 degree of rotation converts to 0.0000463 revolutions per minute. That's how fast the Earth would actually be moving around the sun at just 1 degree a day. Because again, you got to measure that orbit around the sun in revolutions per minute. In revolutions, not orbital velocity. The Earth is not flying around the sun at 67,000 miles per hour. That 67,000 miles per hour is talking about the orbital velocity of the Earth around the sun. How much space the Earth takes up within an hour as it revolves around the sun. You got to remember, the Earth is a massive 25,000 mile object. And as that 25,000 mile object moves around the sun, spatially, it takes up 67,000 miles every hour during that full revolution. Again, the Earth is 25,000 miles in circumference, 25,000 miles wide. So if the Earth moves 1 full amount of space equivalent to its size, it's moved almost 25,000 miles forward. And 2.5 Earth-sized paces forward equals out to 67,000 miles in an hour. You gotta remember, the Earth is a massive circular object making a circular orbit around the sun. You know, it's not moving in a straight line around the sun like it's in a drag race trying to get to the finish line, going 67,000 miles per hour trying to get to the finish line. It's moving in an elliptical orbit around the sun, a 360-degree elliptical orbit. So that 67,000 miles is spread out into a circle, a very long, very stretched out turning motion. Again, it's not speeding straight ahead at 67,000 miles an hour. It's a massive 25,000 mile object within that 360-degree elliptical orbit, being 0.000463 revolutions per minute. And even though the Earth is not rotating at 1,000 miles per hour and moving around the sun at 67,000 miles per hour, with centripetal force, with that constant rotation, constant circular motion, it really wouldn't matter how it orbits or how fast it orbits. Water is still going to stick to that spinning, rotating object once that force is produced on it. Again, any angle, any speed,